Now is it good? Am I audible, team? Okay, fine. So let's again start with this. So this is the control and relay panel. So in this control and relay panel, you can see the feeder 1, feeder 2, both are accommodated in a single panel. So the height of the panel is 2.315 meters and the width is 800 mm. And you can see for feeder 1 BCPU A and feeder 2 BCPU, feeder 1 control breaker control switches, feeder 2 breaker control switches, feeder 1 TBMA and feeder 2 TBMA. Yes, I am presenting some. You're not able to see my screen, team? Okay. Okay. Good. Yeah. So TVMA and TVMB and the test terminal boxes and the relays are accommodated on the top. So at any case, generally these relays we are not having it we are not having any work to do on this. Just at time of commissioning stages, at time of production operator, generally we will reset that switches. But the BCPU, TVM, these we are operating much, so these are to be reached to our hand. So these we should not require. So they are placed on the top. BCPUs next, TVMs there, and last the test terminal boxes. And if I am looking into the dimension of this panel, it is 800 mm into 800 mm. And so this I am considering now. And I am drawing a rectangle 800 into 800 mm. And now this is my room. Now let's check how many panels can I accommodate. So the 1, 2, 3, 4, 5, 6, right? So 6 panels I can accommodate in this room. Suppose 800, 800, 800, 2400 and some gap. So it's totally depends upon your size of the room you selected to mount this. But remember that when you are mounting the panels, ensure that the door should be opened freely. The door should be opened freely. That is the one thing you have to look into. Fine. So let's come back to here again. So this is the panel and this is the panel side view where this is the some slot they provided for the bus wiring between the two panels for LBB trip or for the DC circuit or for Ethernet switch communications between all the panels. And if you are looking into the internal layout in a detail, so it's outskirts the panel. And this we will give the total BOQ bill of material inside the panel and their how they are mounted, what is the model, who is the manufacturer, and everything is mentioned here. So after doing this, these are the things we are generally see. So what we will see in the previous drawings. So mostly in our specification, we will mention, right? So I need, suppose, a supervision relays should be ABB or Siemens or GE make. So whether he provided the same make or whether he is giving from any local market vendors. So these things you have to cross check in the first few pages about the equipment, sorry, device, what he providing to us. Got my point? Yeah. And these are the symbols. These are the symbols. And come to the logic diagram. Logic diagram is simple as a single line diagram. So this is the my protection now I'm talking about. And if you see here, I'm having core 1 for the protection, core 2 for the metering. So core 1 is connected to direction or normal non-directional overcurrent relays, instantaneous and time definite, and under voltage and over voltage relays. And port 2 is directly connected to TVM, and also it is connected to the BCPU, where BCPU also you can need this for to check the number of units generated. The facility is there in the BCPU, so we don't want to lose it, so we are using that feature also in this. So that's the reason we are providing the metering supply to BCPU also. So in the BCPU, you can see these relays. These are inbuilt feature in the BCPU. So that's the reason in this drawing they mentioned inside the BCPU all this. But if you see these relays, trip circuit supervision 2, and master trip relay 86, 86, 1, 86, 2 are the master trip relays, and 95 and 95 2 are the trip circuit supervision, trip supervision relays, and 80 is the DC changeover relay. So these are the not inbuilt feature of this. So I am using these relays as a separate, but all these are accommodated in the control and relay panel. Now let's see. So in this stage, we need to check whether the interlocks mentioned correctly or not. So here you can see the breaker closing in logic. If I want to close the breaker, what conditions I have to check? Let's see. Whether the spring is charged or not. My trip circuits 186. I mean 186 is a trip relay, which is a master trip relay. Master trip relay not operated. LVB trip relay not operated. Trip circuit 1, trip circuit 2 are healthy. Isolator is closed. Isolator B is closed. If all these conditions are satisfied, and then I am giving a command, whether if I am giving a command, close command, if both conditions satisfied, then only the breaker will close. If all these conditions satisfied, then only breaker will close. So breaker closing having some interlocks for human safety. And for the isolate interlock, let's see isolator interlock. Isolator open or close, assume for any case, for whatever the operation, the breaker should be in open condition, and also I am checking the motor supply of the isolator should be healthy. These two conditions I am checking. And now I am giving a command, whether the open command or closed command. So or. So this and this result gives me a open or close of an isolator. And this is also same isolator at switches. If isolator is open, if it is and, then permissible interlock will be there for the at switches. I mean, when that switch is in open condition, when the isolator is in open condition, at switch can be open or close. But when isolator is in closed position, at the switch should not be closed, should be always open. So these are some interlocks things we are checking in this the first pages. And come to the wiring drawing. So from here, our actual scheme will start. So in every schematic drawing team, the first two things we need to know is we have to provide AC supply to that control and relay panel, and also we have to provide DC supply to that control and relay panel. So AC supply and DC supply should be there. So these two circuits should be common for every control and relay panel. So the first thing we will check is AC circuit, whether the AC circuit is there or not. Next one is the DC circuit. DC circuit for the DC supply for all these control and protection units. So in the DC supply, if it is going to all the relays, so the DC supply should be healthy. So there we have to provide a reliable DC supply there, where AC supply not required much. Let's see that. So come to this, the first page here, this is the AC circuit, or else you can see from here also AC supply distribution. This is the AC supply. When you are reviewing the scheme, when you are trying to review the scheme, so you have to look into this grid team. So what is the grid? A, B, C, D, E, F, or this, and 1, 2, 3, 4, 5, 6, 7, 8 this side on the horizontal. These are in the vertical axis, right? Now, let's see. I am providing AC supply to the control and relay panel. So if you enlarge this, if you see in this page, you can see two boxes. This is the one box and this is the one box. If you see on the top of the box, you can find that it's a control and relay panel. So this box, what it's showing here, the box, what it's showing here. Hello, how it is? Still not a still breaking team. Fine. Okay. Now it's fine. Okay. Thanks. So this is the control and relay panel team. So in this control and relay panel, this is my I have to give the supply to this control and relay panel. So from where I am giving the control supply from this control to this control and relay panel, I am giving the supply from the nearby distribution board. So if I see two boxes, it seems that some cable is going from one panel to the other panel. So this panel is a control and relay panel, and to this panel, the supply is coming from the nearby distribution board. It's coming from the nearby distribution board. So the supply is extended and it is connected to the MCB. And from this MCB, it connected to the CFL lamp, thermostat, and thermistor, and also the plug socket with the switch. So this is my AC supply. Just the AC supply is required in the control relay panel for the illumination and for the socket purpose to do any electrical work inside that panel. And this is the DC circuit team. So if you're not aware of this DC circuit, you can see here at the bottom also. This page is talking about DC supply supervision or DC supply distribution. So let's see this. So here also a big box is there, dotted box. This is a CRP panel. So this, whatever inside this whole circuit. So whatever the circuit inside this box, CRP, under the CRP box, this entire wiring will be in the scope of Siemens or ABB who are providing this. Okay. But the cable we have to lay, this is our duty. So this is the main important point where the cable schedule or cable scheduling on termination will start. Preparation of cable schedules. So
why is not clear?
I'm not talking. I'm just looking into this. Here it is heavy rains from the last 10 days. Now it's fine, team.
DC software notes voice not clear, not audible at all.
Okay. Now it's clear. Hello.
Yeah, now it's okay.
Okay. So DC subdistribution board. See, this is the CRP panel, and these are my DC subdistribution boards.
Continue from DC software.
Yeah. I'm starting from there on. This is the DC supply, right? So this page is talking about the DC supply distribution, where you can see this DC supply is coming from a separate distribution boards. So DC supply for the control and relay panel is very important because all the protections and controlling parts are mainly depends on my DC supply. So the DC supply should the provide what we are providing to this control and relay panel should be a reliable supply, should be a reliable. Okay, for that reason, we are having a DC supply 1 and DC supply 2, DC sub distribution board, where from this distribution board, DC supply 1 is coming and DC supply 2 is coming from the DC sub distribution board 2. Now, this DC supply is coming and it is connecting to the DC MCB, MCBs. And after that, this is the DC supervision relay. It is supervising this DC1 and this is the DC supply to supervision relay. And it is continuously monitoring the DC supply. If any changes or if any abnormality is seen by this supply, then I suppose if the DC supply is not there, then this DC changeover relay will operate. This DC changeover relay will operate and it will change these connections. It will make and it will break. So the supply now will extend to this supply also with interruption of the supply. I mean, in a clear way, let's see. At every point, this already I spoken in the previous classes. When you are reviewing the scheme, let's assume the entire all the units, all the contacts inside this control and relay panel circuit are in de-energized state or in de-energized state. Now I am operating this. Let's assume. Suppose this DC supply is failed. This supply is failed. Now, this DC supervision relay will act and it will give so this DC changeover relay give the command to this DC changeover relay. This DC changeover relay will operate and what it will do is it will break the circuit and it will make the circuits. So this DC supply now is extending to this and giving the supply to the DC also. Same thing if you see here at the bottom. In the normal case, when the power is coming, so this will be closed, the supply is extended to this, and this will be closed, and this will be opened up, and this the supply is extending like this. Suppose in case of a DC failure, this DC changeover relay will comes into the action and it will change the contacts which are in open condition. It will make the contact which are in closed condition. It will break the contact. So I can get a reliable DC supply, a continuous DC supply on both ends, even if one of the DC supply is failed. And that you can see in our next one. So this circuit is not completed. It is saying that if you want to continue this circuit, go to that feeder, go to the page number. Sorry. Wait a minute. Sorry. Yeah. So it's saying that go to the page number 15 and identify the Perul number J105. 15 grid 2. So let's go to the 15th page, which is this is sheet 14. Let's come to the 15. Yeah, this is a 15 box 61. So grid 2. Yeah. So it's coming here. Yeah. J104 105. So these are giving this DC supply is going to breaker closing and tripping circuits and feeding to BCPU and 186 master trip relay, breaker closing and tripping circuit 1, BCPU and trip relays. And DC supply 2 is extended to trip circuit 2 and isolator control circuit, LVP trip relay and on other Ethernet switches and again. And it again extended to the other part also. Team not audible. If not, if you're all facing the same, we can stop here and we can continue tomorrow. Hello. Hello.
Yes, sir.
Okay, then. So we'll stop here and we will continue this in our next session. Yeah. Let me check pull if all these things better, then we can have a class. Sure. Okay, team. Good night, and we can continue the rest of the class in our. If I can find a good network tomorrow, we'll have. Otherwise, on some other day, I will update by tomorrow evening. Okay. Thank you, team. Good night.